All right, on today's episode of Python Papi, we're back inside our TensorFlow course. And yesterday we finished up our malaria building cognates module, and today we picked up in our malaria binary cross entropy loss module. Let's see what we went over today. So now we're building a model. So let's move on to the error sanctioning section. For error sanctioning binary classification problems, we generally use the binary cross entropy loss. Let's look at this formula of the binary cross entropy loss from an ML cheat sheet website. So this is the formula here. We have math and binary classification where the number of classes m equals 2. Cross entropy can be calculated as negative y log p plus 1 take away y log 1 take away p. So y is actual and p is predicted. If m is greater than 2, i.e. multi-class classification, we calculate a separate loss for each class label per observation and sum and result. So this will be that equation here. We have the M for the classification or the multi-class classification. Take away the omega. C equals 1. We have the Y is the actual. OC log predicted OC. Now, just as most error sanctioning functions with a binary cross entropy, we're trying to penalize the model when the actual prediction, actual Y, is different from the predicted value, predicted P. And so in this case of a binary classification problem, if our actual prediction is meant to be a 1 and our model predicts a 0, putting that into the equation will get us a 1 log 0. So we have a 1 for actual, log, and then 0 for predicted. So here we would have a 1 log 0, and then we have 1 minus 1, which is 0, with a log of 1, since p is 0 and 1 minus 0 is 1. This will be the equation here. It's the same as the one above. We just replace the zeros, or we replace the y's and the p's with the 1 and the 0. So let me give you a look. Just take a look at this one right here. And we'll go and show you the original equation. So that's the same as this. We just switched out the y and the p with their numbers. So we have the y, which was 1, and the p, which was 0. Or the y was the actual, and the predicted was 0. So as you can see, we replace all of the numbers, or all the letters, with their corresponding numbers. So you can see here we have the negative 1 log 0 plus 1 take away 1 log of 1. Now we only have a log of 1 here as opposed to the 1 take away p, because as you remember, the p is 0, so 1 take away 0 is 1. So we just leave that off and leave it as log 1. And that's what I'm going to leave it for now. We did go a lot deeper, and we did do some actual graphing and plotting, but I'm not going to dive into that today because we're just getting started with the module. But we will pick it up tomorrow, and I will keep you guys posted every step of the way. But for now, this is the Python Papi. You guys stay Gucci.